In the previous two examples, we had the summary statistics. This time we have the actual data, so the first thing we're going to have to do when we go to our calculator to work with this problem is to enter the data into two lists. So again, you can read through this problem yourself, pause the video, read through it carefully, and then watch the explanation of the solution. Okay. So we have scientists here that are manipulating corn to try to create a variety of corn that will help the chicks grow better. And they have some control and experimental data on this. So part A, present the data graphically. Are there outliers or strong skewness that might prevent the use of t-procedures? So you could do either histograms or box plots. I took my calculator and did box plots. Okay, so you have to enter the two lists. I put them in L1 and L2. And go in and turn on the stat plot and choose the box plot. Where it asks whether or not there are outliers or strong skewness, so I chose the one with the two little dots. That means it's going to test to see if there are outliers. And there's the first one, and there's the second one. The second one's pretty close to symmetric. It looks really symmetric to me. The other one looks like it's a little skewed to the right, but not too bad, and there's no outliers, so it's pretty safe with these sample sizes to go ahead and use the t-procedures. Part B, is there good evidence that chick-fed high lysine corn gain weight faster? Carry out a test and report your conclusions. So again, we've already entered the data. So you hit Stat, go over to the test menu, select the two-sample t-test again as on the previous examples, but this time select Data instead of Stats, and you tell it where they are. Okay? So I put the lists in L1 and L2, so I tell it that. Leave the frequencies at 1 unless you're using lists to use large frequencies of numbers, but when you enter the actual data, leave those at 1. And for the choice, again, we have to read the problem and see whether it should be one-sided or two-sided. Here they believe that the corn that's been treated are going to make the chicks grow more than the others, so we expect that mu2 is going to be bigger, or mu1 is going to be less than mu2. The control group, those are going to have a smaller mean weights than the experimental group. So I select the less than mu2 and leave it on no. Go down and calculate or draw. Again, we're testing the null hypothesis that mu1 equals mu2 versus the alternative, one-sided, mu1 less than mu2. I selected draw, got the t-value negative 2.469 and the p-value of 0.0092. So a small p-value. So at even the 1% level, we would reject the null hypothesis. So yes, there's good evidence that chicks fed high lysine corn gain weight faster than the chicks fed the normal corn. And then you can also do confidence intervals. It says give a 95% confidence interval for the mean extra weight gain in chicks fed high lysine corn. So what they're talking about here, we've already, through parts A and B, decided that the chicks in the experimental group are bigger. They've gained more weight. So we could look at the differences, which would be mu2. If we wanted them to be positive, we would actually look at mu2 minus mu1 to see that those are positive numbers, that it's bigger in the experimental group. So I'm going to do a 95% confidence interval for mu2 minus mu1 with my calculator. And so if you go over to the test and you drop down, you have to scroll down a little bit, but you'll find two sample t intervals. And again, we have the data, so I tell it data. And you'll notice I've switched L1 and L2 here because I want it to give me positive numbers when it computes these. So I'm going to do mu2 minus mu1, experimental minus control, because we believe experimental are larger. So I put L1 into list 1. Sorry, I'm saying that wrong. I put L2 into list 1 and L1 into list 2. Okay. So I want the experimental group to be the first list it uses and the control group to be the second. So I've swapped L1 and L2 there. It said 95% confidence level, so the C level there, I put 0.95. And select no, and then drop down and calculate it. And there's the output. It repeats the numbers that it gives you the summary statistics. We gave it the data here, so it gives you those summary statistics and the degrees of freedom, but at the very top there you have the interval. Okay? And the important thing here is at the 5% level, 95% confidence level, we have an interval that's all positive. So we're 95% confident that, yes, the difference between these is positive. The experimental group is growing at a higher rate than the control group.